Namaste all. Let us go for the next problem. In the previous class, we have find out the derivative of continuous function sin x, which is one of the important function which we have always used in our problems. Now, the next part, which is a derivative of cos x. So, let us find that by first principle method. So, according to the first principle method, dy by dx is nothing but limit as h tending to 0 f of x plus h minus f of x divided by h. We have y equal to f of x is the continuous function. Now let us find the derivative of cos x. Okay. So derivative of cos x, we know that cos x is also one of the continuous function. Whenever f of x equal to cos x, f of x plus h will be equal to cos of x plus h. Right. So dy by dx. Substituting all the values in the formula, limit as h tending to 0, f of x plus h is cos of x plus h minus f of x value is cos x divided by h. So this will be equal to limit as h tending to 0. We know the formula cos a minus cos b. Let us recall that. So cos a minus cos b. Cos a minus cos b is equal to minus 2 sine a plus b by 2 into sine of a minus b by 2, right? So in the place of a, we have x plus h, and in the place of b, we have x. So let us apply this. The term will be limit as h tending to 0 minus 2 sine a plus b is there, that is x plus h a plus b by 2 into sine of a minus b, that is x plus h minus x divided by 2 whole divided by h is there. So this will be equal to limit as h tending to 0 minus 2 sine, here x plus x is 2x plus h divided by 2 into, here x will get cancels, sine h by 2 divided by h. So now we can continue this. This will be limit as h tending to 0. As you know, I have already told in the previous class that this limit as theta tending to 0, sine theta divided by theta will be equal to 1, which is the basic formula or result. Applying this result here sine h by 2 is there, here h is there, sine theta by theta, here in the place of theta we have h by 2, which implies here also we need h by 2. So I will do h by 2. Whenever we divide by 2, we need to multiply by 2 here. So let us combine this together so that we'll get the limit value as 1. Whenever the value of theta tending to 0, in the place of theta we have h by 2. Whenever h tending to 0 as in the problem, h by 2 will also get the value 0 itself. Right? So let us apply this. We get minus 2 into sine of 2x plus h divided by 2 whole divided by 2 is there into, here the value is 1. Okay, so here the value is 1. Now we can cancel this 2 and 2. We left with, we can notice here whenever h tending to 0, this value will get the 0. So we left with minus sine of 2x by 2. Here h value 0. Here also we can cancel 2 and 2. We left with minus sine x. which implies d by dx of derivative of, we are finding cos x, right? So d by dx of cos x is equal to minus sin x, which is also one of the important formula which we have used, which we will be used in our next classes, further classes. Okay, please note this out. Again, we'll meet with some more problems in the next class or next video.